All right, so for everybody at home, we're doing lecture 15, function inverses. I wanted to do a couple definitions to get us started, and then we'll be going over some classwork problems. So let's look at the first definition. All right, we're going to suppose f is a function, a bijective function, and we're going to assume that it maps x to y. Okay, so we've got a function f, and it's mapping x to y. We know that x is going to be the domain, and we know that y is going to be the range. Then the inverse function f negative 1, f inverse, is the function that maps y to x. And this is called the inverse function. All right, I'm gonna dim the lights a little bit so you guys can see. There we go. Okay, so if we have a function f and we know it's bijective, then we know that it has an inverse function. And we call that f inverse, or f negative 1. Now, if this is true, then we can compose these two functions and we get back x. So we can say if we compose f with f inverse and we evaluate at x, we get x back. And we can also go in the reverse order. We could have f inverse composed with f. If we evaluate that at x, then we'll also get back x. So the order of it shouldn't matter. If you compose a function with its inverse, you're always going to get back what you put in. So the input is always the same as the output. Okay. We can also say that if f has an inverse, then the function is invertible. So we say function f is invertible. Okay, one more note before we move on from this. This is very important, so I'll put a star beside it. Not all functions are invertible. Not all functions are invertible. Now, for a function to be invertible, it actually has to be a special type of function called a bijection. And that's where the word bijective comes from up here. So I'll underline that. So for every single function that I give you in the classwork or the problem sets, those functions will be invertible. But there are some that we'll talk about today that are not invertible. And you'll see that a little bit later. Okay, let's move on to the next slide and let's talk about the inverse of a point. Okay, so the inverse of ordered pair x comma y, if you're given an ordered pair like this, then the inverse of that ordered pair is y comma x. So all I'm doing is I'm just switching the order of the x and y, and that's called inverting the point. You're just switching x and y around. Okay, so now let's learn about how to find an inverse. And to find an inverse, you need to follow this 4-step process that I'm about to give you. So to find the inverse of f, you need to do 4 things. The first thing that you want to do is you want to replace f of x with y. You want to replace f of x with y. The reason why we do that is because it's easier to work with x and y than it is to work with x and f of x. And once again, we're just replacing f of x with y. The second step that you need to do is you need to interchange x and y. That just means switch them around. So we're going to interchange x and y. I'll show you what that looks like when we do our example. Now, once you've interchanged x and y, you've switched them around. Now you need to solve for y. Solve for y. And what that basically means is you want to get y by itself on one side. So get y by itself on one side so that everything else will be on the other side. And then once you've solved for y, you've gotten y by itself. Well, then the last thing you need to do is you need to replace y with the inverse notation. Replace y with f inverse of x. So I'll keep this up there for about a minute so you can copy this down, but these are the 4 steps that you need to go through to find the inverse. All right, now for all 5 classwork problems, what we're going to do is we're going to be given a function, f of x, and what we need to do is we need to find its inverse, f inverse of x. And then what we're going to do after that is we're going to verify that they are inverses of each other by composition. So let's take a look at the classwork and let's do number 1 together. Okay, so they give us the function 2x minus 8. So the first thing that I want to do is I want to replace f of x with y. So what I'm going to do is I'm going to replace this f of x, this function notation right here, I'm going to switch it with y. So then I get y equals 2x minus 8. After we've done that, we're going to move on to step 2. We're going to interchange x and y. So that means we're going to switch x and y around. Everywhere I see a y, I'm going to write an x. And everywhere I see an x, I'm going to write a y. And I get x equals 2y minus 8. All right. So the third step that we need to do is we need to solve for y. We need to get y by itself somehow. How can we do that? Well, we can get y by itself on the right side. We would just have to get rid of 2 things. We're going to get rid of the minus 8. We're going to do that first. And then we're going to get rid of this 2 that's out in front. Now, to get rid of a minus 8, I need to add 8 to both sides. And what that'll do is it'll cancel out the minus 8 on the right side. So these are going to cancel out. And I'm only left with 2y on the right side. But on the left side, I'm going to have x plus 8. The last thing that I need to do is I need to get rid of the 2 that's in front of the y. And I can do that by dividing both sides by 2. Make sure that when you divide both sides by 2, you draw your fraction bar under the x and the plus 8. That's very important. What that does is it's going to cancel out the 2's on the right side. So I'm left with y equals x plus 8 over 2. That's going to be my inverse function. So now that I've solved for y, what does step 4 say? Step 4 says replace y with f inverse. So I'm going to do that. And when I do that, I write f inverse of x. It's going to look like f of x, but it's going to look like it has an exponent of -1 on top of the f. It's really not an exponent. It's just inverse notation. And then I'm going to keep this part the same, the x plus 8 over 2. That's my inverse function. Okay. So the last thing that we're going to do is we're going to verify that these 2 functions are inverses of each other. So what I need to do is I need to compose them together. So I'm going to take f and I'm going to compose it with f inverse. Now what this is going to do is it's going to take the inverse function and put it inside of the regular function. So the composition is going to look like this. Now my inverse function, I'm going to put that on the inside. X plus 8 over 2. So now what this means is everywhere I see an x in my regular function, I'm going to replace that with x plus 8 over 2. So what was my original function? That was 2x minus 8. So I'm going to have 2x, but I'm going to replace the x with an x plus 8 over 2 just to see what happens. And then after I close up that parentheses, I'm going to have a minus 8 off to the side. And that's just because I have a minus 8 right here. Okay, so after that, a lot of things are going to cancel. First of all, the 2's, they're going to cancel out. I have 1 on the top and 1 on the bottom, so they're gone. I also have x plus 8 minus 8. The plus 8 and the minus 8 are going to cancel each other out. So the only thing that I'm left with at the end is going to be the x. And you should always get x for your answer, because that's going to tell you that these functions are inverses of each other. Let's try number 3 together. Number 3 gives us h of x is equal to the cube root of x plus 5. So this is a cube root function, and I want to find its inverse. So the first thing that I'm going to do is I'm going to replace my h of x with a y. I can do that because they're considered to be the same thing. And I'm going to keep the right side the same for now. So all I've done is I've replaced h of x with a y. The next thing I'm going to do is I'm going to switch x and y around. So x is going to be on the left side, and y is going to be under the radical. I'm going to get cube root of y plus 5. I'm just changing that x into a y. So we've switched x and y around. Now the third step is to solve for y. I want to get y by itself on the right side. But to do that, I'm going to need to get rid of 2 things. I need to get rid of the cube root right here. I'll do that first. It's pretty hard to get to the plus 5 without getting rid of it. So that's why I'm doing that first. And then at the very end, we're going to get rid of this plus 5 right here. So to get rid of a cube root, you need to cube both sides. So what I'm going to do is I'm going to put parentheses around the x, and I'm going to cube it. And I'm also going to put parentheses around the cube root, and I'm going to put an exponent of 3 on the outside. So what that does is it leaves me with x cubed on the left side. On the right side, the exponent 3 and the cube root index of 3 are going to cancel each other out. And whatever's on the inside of the radical sign is just going to come out. So the y plus 5 is going to come out. So the last thing I need to do now to get y by itself is to get rid of the plus 5. And that's pretty easy. All I need to do is subtract 5 from both sides. That'll cancel out the plus 5, and I'm left with y is equal to x cubed minus 5. That's going to be my inverse function. So I'm going to replace y with the inverse notation. H inverse of x is equal to x cubed minus 5. That's going to be my inverse of h of x. So now we need to verify that they are actually inverses. What I'm going to do is I'm going to compose the 2 functions together, put one of them inside of the other, and then I'm going to see if I get x at the end. And if I do, that's good. That means that they are inverses. So let's do that on the right side. We're going to verify. So I'm going to take h, and I'm going to compose it with h inverse. And when I evaluate at x, I want to see if I get x back. So I'm going to put a question mark above the equal sign, because I don't know if it's true yet. Okay, so the h is going to come first, and then I'm going to have h inverse on the inside. So when I compose two functions, I'm taking the function on the inside and I'm putting it inside of the function that's on the outside. So h of x is the cube root. So I'm going to have the cube root of what? The cube root of x plus 5, right? That's what my original function is. But I'm going to replace the x with my inverse function that I found right here. So on the inside, I'm going to have x cubed minus 5, and then there's going to be a plus 5 on the inside. And that's going to help us out later, because the minus 5 and the plus 5 are going to cancel each other out. So I'm left with the cube root of x cubed. The exponent is 3. The index of the cube root is also 3. So that means that they cancel out and I'm left with x. So I know that these two functions are indeed inverses. Okay, so I'll leave that up there for a little bit. What I wanted to do now is show you what these two functions look like when you graph them. So what I'm going to do is, in a minute, I'm going to go over to Desmos. We're going to graph the two functions and see what they look like, because there is going to be a pattern that all inverses are going to take. So let's look at that. Okay, so here I have my graphing calculator. On the left side, I'm going to put in my first function, h of x. And h of x is going to be equal to the cube root of x plus 5. Now, since I don't really have a cube root button on my keyboard, there is a keyboard at the bottom of the screen that I'm going to pull up, and it's going to have many more functions for you to choose from. So what I'm going to do is I'm going to go over here to where it says functions, and I'm going to find the cube root. So under miscellaneous, you will see this cube root radical right here. The index is actually to be determined. So I'm going to hit this, and I'm going to let the index be 3 since it's a cube root function. And then on the inside of the radical, I can put my x plus 5. And that is what my first function looks like. It's got that familiar shape to it. It's got that cube root shape. That's going to be my blue function. Now my inverse, I want to make it a red function, so I'm going to change the color. And I want to put in h inverse of x. Now, since I don't have inverse notation on here, I'm going to use f of x instead. And we know that the inverse was x cubed minus 5. So I'm going to type that in, x cubed minus 5, and I'm going to change this to red. So the blue function that you see and the red function that you see are inverses of each other. Now these have a special type of symmetry to it, or it looks like they have a symmetry to it, right? The last function that I'm going to put on my screen is y equals x. Y equals x. And I'll make this a black line. So do you notice the symmetry now? If you take the blue function and you rotate it around the black line, you'll get the red function. And if you were to take the red function and rotate it around the black line, you would get the blue function. So a function and its inverse they always have symmetry when you graph them. And the symmetry is around the line y equals x. So that's an interesting thing to think about. Okay, so that's number 3. Let's go ahead and try number 5 together. Okay, so number 5 is q of x is equal to ln of x. Now, ln just stands for natural logarithm. So we can actually rewrite this as a logarithmic function with a base of e. So I'm just rewriting the function. And what we need to do with this function is we need to follow those 4 steps that we talked about. The first thing that I'm going to do is I'm going to replace q of x with a y. I'm going to replace q of x with a y. But everything else is going to stay the same. I still have logarithm base e of x. The next thing that I need to do is I need to switch x and y around. So the y is going to be an x now, and the x is going to be a y now. Okay, so now I'm moving on to step 3, which is solve for y. I need to find some way to get y by itself, which means I need to get rid of this logarithm right here. I need to get rid of this logarithm somehow. So we learned last week that we can get rid of a logarithm if we use an exponential function. And I'm going to use the base to do that. Remember how we said the base is always going to be under the g of the logarithm? Well, this time our base is going to be e. E is just a number. So I'm going to use e as my new base. E is going to be the new base. So notice what I'm doing here. I'm letting both sides be the new exponents. So the x on the left side is going to be the exponent on the base. And on the right side, that logarithm base e of y, that's going to become the new exponent on the base of e. So what that does is it actually cancels out the logarithm on the right side, because this base of e right here is going to cancel out with this base of e right here. And what am I left with once I cross both of those out? I'm left with this y right here. And that's just going to come down to my final answer. What do I have on the left side? E to the x power. So the last thing I'm going to do is I'm going to write my inverse notation. And that's my inverse. Notice that I have q inverse of x now. Okay, so let's verify that these two functions are inverses of each other. I'm going to do that on the right side. We're going to verify by composition. So I'm going to take q and I'm going to compose it with q inverse. And once I evaluate at x, I should get x back. But I'm going to put a question mark because we don't know yet. Okay, so I'm going to expand this out a little bit like this. Notice that Q inverse is on the inside, Q is on the outside. We know that Q inverse of X was e to the X power. I found that down here. So I'm going to put that on the inside. And now I'm taking my original function of Q of X and I'm evaluating it at e to the X power. So I'm going to get the natural log of e to the X power. We know that natural log is the same thing as log with a base of e. So I can rewrite my natural log as log base e. And then what happens is the two bases are going to cancel each other out. So the base of the logarithm is an e, right? And then the base of the exponential function is an e as well. So I can cross that out. And then what am I left with? Just an x. So we know that these two functions are inverses. So let's take a look at what these two functions look like when you graph them. I'm going to go to Desmos, and I'm going to show you what that's going to look like. Okay, so let me get rid of all this stuff. We're going to let Q of X, we're going to let Q of X be the natural log of X. We get that function right there. I'm going to change it to red. We're also going to have another function, which is going to be the inverse. I'm just going to call it f of x. And it's going to be equal to e to the x power. That's the inverse that we found. And I'm going to change this to be a blue function. So look at the two functions we have right here. Is the blue function the inverse of the red function? If it has that symmetry that we talked about, then they are inverses. The last function that I'm going to graph is y equals x. Y equals x. And I'm going to make that a black solid line. So notice that if you rotate the red function, it's going to become the blue function. And if you rotate the blue function, it's going to become the red function. So a function and its inverse are always going to have that symmetry to it. Okay, so back on my slide, I'm going to leave this up there for about a minute so you guys can finish copying that down. And then we'll talk about what's going to be due at the end of the week. Okay, so there's going to be two things. There's going to be the composition classwork and the inverses classwork. Those will both be due on Sunday. If you have any questions about this, leave it in the chat box. Remember that I have office hours every day at 2:15. So if you need help, click on the office hours link on my Canvas homepage. And I think that's all I had to talk about. All right, so class dismissed. I will see everybody on Monday.